All right, welcome to the next section in our course where we will start setting up our light rigs. First of all, I want to show you the shots we're going to work on, which is in the HDB sequence. You can open up the play blasts as well. And it's basically HDB 10, HDB 30, and HDB 50. So you can see it's basically a samurai walking towards the window. And the last one is a shot which plays in a different room. And you can see that the first two shots are quite similar. The last shot is in a night time or night scenario and very different lighting, very different location. So we're going to right now concentrate on HB 10, HB 30 and set up a sequence light rig and a sequence setup for this. The last shot is going to be an exercise for you guys to work on after we've done the first two shots. And our goal will be to create a generic setup, which we can, as much as possible, reuse between both shots. I think the main difference will be that the HDRIs are going to be different, just because where the shot starts. But if you look at the light fixtures or the practical lights, it's in the same location. It's in a flat, so the lights will be quite similar. So those we most likely will be able to reuse without a problem and without modification between both shots. So now let's go into Katana. And the first thing I want to do is set up the frame ranges. Unfortunately, they don't get set automatically. So to define the frame ranges, you need to go to the project settings. And in there, you can set the in time and the out time. That sets your frame range. If you look at the bottom, there's also a in and out point. But if you set it there, Katana won't remember it in the scene file. So it'll get reset every time you open up the scene because it looks at the project settings. So the frame ranges for your shots, if you look in the shot under cache, there's a frame range.txt. And we want to set it up for HDB10. So if you look at this frame range, it's from 1001 to 1125. So set it up and set the in time and out time. And the reason we're starting at 1001, you'll find this to be true at a lot of companies, is you want to be able to have a pre-roll for the animation, not necessarily for lighting, but for other departments like FX, Credev, for cloth simulations and or FX caches. So starting at a number higher than 1 means that if the pre-roll will still be in positive numbers, working with negative frames can cause often problems in pipelines. So that's the main reason we don't start at frame 1. And this can be different at every company. All right, now that we've set the frame range up, we're going to start setting up the light rig structure and create a sequence lighting setup. If you look at it from a shot time perspective, or the time you have to actually finish the lighting for a shot, we're going to spend in the setup phase, in the phase of setting up your base light rig and validating it, we're going to spend about 20% of your shot allocation. In another ways, you're spending 20% of your time to get your lighting to 80%, and then you will spend 80% of the time to do the final 20%, because those are the most difficult steps and the most subjective steps. We can now set up our light rigs. So in a template, if you navigate to the sequence setup, you can see the Gaffer 3 node we had set up. And that's going to be the main node we are going to work with. This is Katana's lighting super node called Gaffer 3. So it's good to get familiar with this. You can either select a node graph, or there's also a tab called Gaffer 3 you can switch to. If you have more than one Gaffer node, it'll actually let you select the different gaffers in here. But now with just one gaffer, it'll just display this one. Now we're creating a sequence lighting setup, so we need to take that into consideration when we create the structure for our light rig. What I like to do after looking at a sequence and kind of trying to identify which lights we need, I create one light rig per sequence. If it's a bigger sequence with subsequences, I usually create separate subsequences for it. So the first thing I'll create is a rig, and you can go to Add, Rig, and you can also just hit R and double click on it and type in HDB for the HDB sequence. And in there, I'll create another rig and I'll call this env. And this is where we are going to have our environment lights with the HDRIs. And then I'll add another rig. I need to select the HDB and hit R. And then you can create a rig and I will call this set lights. And in set lights, we are going to create the lights which are the practicals on set or set lights from the shot. And the main reason is we move the set lights around, so I want separate control over that. Having a set lights node or locator lets you move the entire group around in one go. If you open up the root world light gaffer, you can see the structure in the scene graph. So kind of just matches what you see in the gaffer 3 node. And you're not going to see anything in the Hydra because these are just locators. If you select any of these of the rig, you can move it around with a transform. So the first thing, we're going to create an environment light. So select the env rig and right click on it, add 3D light. 3D light comes with presets for its light, so that's the easiest way to create it. So select the environment light and switch to material. And in here, we want to load our color corrected HDRI. So navigate to the folder where we wrote out our TDL files. We want to select the color corrected environment map, inclusive the lights, because that's going to make it easier to orient the HDRI correctly. Hit accept, and that's it. This is our base structure of our light rig. And that's it. Thank you. So with our environment light setup, we are almost ready to start the lighting process. We'll take a quick look in Nuke to look at the reference spheres which were shot on set. So to set up our light rig and to validate it, we will have to create the chrome gray spheres in CG, position them at the same point in space as the reference shoot, and try to match lighting, and to that validate our lighting setup. Okay, looking at the ref spheres, we will have to match the position in Katana. So let's switch back to Katana. If you look at the chrome gray sphere setup we imported when we built our template here, there are actually a few steps still missing for this to work. We look at the chrome sphere pass and expand the scene graph down to world georef. And if you open that up, you can see that the constraints are throwing some errors that the geometry can't be found. We have to do a few more steps, create the geometry, the sphere geometry, import the shaders, and also set up the shot work for the spheres. So let's import the sphere geometry. And you can go to File, Import, and navigate to the Katana nodes folder and import the sphere geom.katana file. Place the node in the setup section, just right under the variable switch node. And if you double click on the node and expand the scene graph, you can see the chrome gray sphere setup, including the Macbeth geometry. So just merge this with the mainstream. And now with the geometry merged in, if you go down to the chrome sphere pass and view the scene graph from there, you can see the errors are gone and you can see the chrome sphere, the gray sphere, and the Macbeth chart. Now let's go to the material section to import the material shaders. Again, go to File, Import. Under Katana nodes, there's a reference sphere shader.katana file. Import that and you'll get a material stack. And this material stack includes the default shader as well as the chrome and gray sphere shader. So you can just delete the original material stack and replace it with the imported one. And I'm just going to rename it, remove the one. And let me show you the shader settings quickly. So if you select the gray shader and open up base, you can see I've set the color to 18% gray, so the mid gray value. And specular level and metallic is set to 0, so there's no specular response. This is a pure diffuse shader. If you look at the chrome shader, you can see the specular level is set to 0, but metallic is set to 1. So that means that the response is completely reflective, So it's like a chrome material, a mirror-like material. Okay, with this base material setup, we are almost done. You don't have to set up any material assignments. The material assignments are happening in the sphere path setup. Actually, let me go into the sphere path setup and show you how it's working. So if you look at the setup, I'm creating the cameras in here, and what they do I'll show you in a second, as well as doing all the material assignments, a few attribute settings for the geometry, and the biggest part is the constraints set up for the cameras. If you look at the Chrome path and look through the shot camera, right now you can see we're not seeing any Chrome gray spheres because they are still at 0, 0, 0. So we'll move the Chrome gray spheres into the correct position later. But if you look at the camera list, you can also see a Chrome and gray cam. And if you look through the gray cam, for example, you can see it's pointing actually at the gray sphere as kind of framing it into the center of the image. And so if we expand the shot camera and display it, what I'm doing here, and if you select the gray cam and hit F to focus on it, you can see it's positioned exactly where the shot camera is. The way I'm achieving that is through those constraints I mentioned earlier. And so the way this works, we look back into the sphere path setup. I've got 3 constraints: a point constraint, an aim constraint, and an FOV constraint. The point constraint constrains the sphere cameras to the existing shot camera, and the aim constraint orients the sphere cameras to the spheres. So gray camera at the gray sphere, chrome camera at the chrome sphere, and so on. And the FOV constraint makes sure that no matter how far away the chrome spheres are, the FOV centers the sphere, basically making it full screen in the image so we can always see what's going on. So the last step which is missing are the controls to position the chrome gray spheres into the right position so we can match what we see in the reference shot. So again, go to File, Import, and import the reference spheres _veg.katana and connect it inside of the shotwork for HDB10. What we have here is a variable enabled group, and if you go inside of the group, you can see 2 nodes, an isolate node and a transform node. So if you look at the settings for the variable enabled group, you can see the variable name is set to pass and the pattern to sphere and chart. And what this means is this group will be only active if the passes end with sphere or end with chart. So if you look at the sphere passes, you can see they either end with sphere or chart. So with the chrome sphere and gray sphere and Macbeth chart, the VEG will be enabled. If you take a look inside, like I mentioned earlier, there's an isolate and a transform node. And the isolate node is the reason we have to use a variable enabled group, because in the isolate node, I'm isolating down to just the reference spheres. Most of the times that is enough. Like, you don't need the characters, or you don't want the characters in there, or the set, because they modify or change the lighting, because you really just want to purely read the light rig. There are certain circumstances where you do want a set, but most of the times everything else you would remove. But if you had that isolate node always in a shot work, all the other passes would not work, but we still want the flexibility to change the isolate per shot. So this is the main reason we are using a VEG node. So yeah, with the transform 3D, it points at the spheres location or spheres group. So if you select spheres, hit W in the viewport, you'll get the transform locator, and you can move the spheres around. You might have noticed in the transform 3D node, the scale is set to 9.84. The reason being the spheres on set, the physical ones were 25 centimeters in diameter, but the units in Katana are in inches, so 25 centimeters are roughly 9.84 inches. Now we are ready to position the chrome and gray spheres. Just to remind ourselves, if we go into Nuke and take a quick look at the reference footage, we can kind of see where the spheres are positioned. You can see the window on the left, and it seems the chrome ball is slightly behind the window and maybe half a meter off the wall. If we zoom in into the chrome sphere, you can see the tripod stand legs start roughly where the wall and the window meet, or where the wall ends. Okay, so let's go back to Katana. And the first thing we do is view the scene graph from the Chrome Sphere pass, or any of these passes really. Right now we don't see the set, but I want it to be visible. So I switch off the isolate node, because with the set I can gauge where everything is. Expand the set HTTP to its component, and it'll display it in the viewer. And here you can see where the shot camera is, and the window. So we kind of know where the spheres roughly should be. And as a starting point, I'll just roughly move them into the right location. So select the sphere group and transform the spheres roughly into the position where they should be. I think it's something like this. It doesn't have to be too exact, but we will set this up in a way how we can easily check if the position is right. Now, looking through the shot camera, it's hard to tell if it's really in the correct position. The other thing you want to set actually is also the frame you are on. If you scrub through the timeline, you can see the camera is doing a rotation. And if you remember the reference image, the window is just off in the corner. So I think around 1020, 1017. Yeah, I think 1070 looks good. The position is probably not right for the spheres, but I'll show you a way how to verify this easier. Since we have the reference footage, we should use it. So go to Catalog and File Import, and we're going to load the reference footage from HTTP10 in the Elements folder, Reference, and there load the neutralized plate. Now, if you go to the monitor, there's the image, and there's a little icon up here, which is a toggle for overlay and underlay controls. So switch that on, and you should get an underlay field. Now you can just middle mouse drag the image into the underlay field. And what this does is every time we render, this image will be the background. Because this is going to be an interactive session, I want to see my monitor the same time as the viewer. So I select the viewer tab and reorganize my layout a little bit. And just move it down to the bottom so I can see both at the same time. Now I want to render my spheres. The only problem is if you render from the pass, the camera switches automatically to the Chrome camera, and that's not what we want. But the way I have set up the reference passes, if you want to render from the original shot camera, instead of the sphere cams, you can render from any of the variable set nodes. So if you render from here, you will see the camera jumps back to the shot camera, and now it'll render the entire Chrome and Gray sphere setup. This can be a good guide to position the Chrome and Gray spheres. And now I can move the spheres and change the position. But because I didn't do an interactive render, let me switch on live renders. So shift left click on the spheres, because I want these to be updated every time I move them. So, and now you can right click and select live render. And now every time I move the spheres, the render will update at the same time with a slight delay. And this is a quick way to figure out the position of the spheres. And just spend some time moving them. It won't be perfect, but we just want it to be as close as possible. Okay, now that we've positioned our spheres and they're kind of in the correct spot, we can start lighting and switch the isolate node back on.